Okay, in this question, point P represents a complex number Z in an Argand diagram. Okay, what is an Argand diagram? Argand diagram is a diagram where this part represents the imaginary. Okay, so the vertical axis represents the imaginary part of Z, and the horizontal axis represents the real part of Z. And what do I mean by imaginary or real part of Z? Suppose I have a Z complex number called A plus BI. A is the real part of Z, whereas B is the imaginary part of Z. Not BI, but just B. So in this case, this is the idea. So let's say if I have like 3 plus 4i, then I have 3 and 4 here. This will represent my 3 plus 4i. Okay, so another idea that we need to have for solving this problem is that when Z minus Z1, where Z1 is a particular complex number and Z is the variable. It's a variable, that means and Z1 is a particular coordinate. So for example, some non-point like 3 plus 4i. Right. When we have this modulus, it just means that the distance between that variable and this Z1 equals to, let's say, equals to something A. That means the distance, that means if I have Z1 somewhere here, then the distance of this variable Z is A units from Z1. The distance between them is A. So given that Z is a variable and unknown, it could be anywhere that is a distance of A from Z1. So you will trace out a circle with radius A. So this is something that we need to know. So here, since we have taking all these ideas in mind, since we have this thing can be rewritten as Z minus. It's important that this is a minus, right? Then minus 2 plus 2 root 3i equals to 2. Okay, so let's draw this point first, this coordinate. This coordinate is the real part is minus 2. The imaginary part is 2 root 3. So I do not 2 root 3 here. Right. And they say that the Z, the distance of this unknown variable from this point is equals to 2. So I just need to put a point here. Then this is my Z1. I can call it the Z1. And then the distance from it is 2. So 2 root 3 is more than 2. So I expect the 2 to be somewhere. This point would be my 2 root 3 minus 2. This point will be my 2 root 3 plus 2, and this one minus 2 plus 2 will give me somewhere here. So you can see that my locus should be somewhere here, where this point would be minus 4. This is a circle of radius 2 centered at this point, minus 2 plus 2 root 3i. That's the locus of P. So P can be anywhere on the circumference, on the perimeter of the circle. Could be anywhere, because anywhere on the perimeter of circle is a distance of 2 away from this point at the center, which is satisfying what the equation is saying. The equation is saying that this unknown is a distance of 2 from this point, and every point on this circle satisfy that hint, satisfy that clue. Now write down the minimum value of arc Z. Now the minimum value of argument Z can be written as argument Z is equals to argument Z minus 0, which means Z the angle, okay, when I say, then let's come to this idea first. So when I say arc z minus z1 equals to 30 degrees, for example, it just means that z is an unknown that has a 30 degree, that is 30 degrees when measured from z1. So z1, this is parallel to the horizontal axis. That means this z can be anywhere on this line, because anywhere on this line except that point is 30 degrees when measured from z1. How do we measure something? So from z1, when we measure from, it's always, let's say if I have a point here and measuring let's say another point here, so what is the angle of this point from this point? I would first draw a dotted line parallel to the horizontal axis and line joining them. So then I will measure this angle. Remember, we measure from here. If we say measure the angle of A from B, in other words, arc A minus B is this. So it's the angle of A measured from B, right? So this is the angle of Z measured from Z1 is 30 degrees. It's 30 degrees over here. So with this concept, then we can find what is the minimum value of argument Z. Since Z is anywhere on this circle, correct? And we are measuring from Argz, right? Means Argz minus 0. That means we are measuring Z from the 0, and 0 is the point 0 plus 0i, meaning it is the origin on the Argand diagram. And let's say Z is somewhere here. It will give me the minimum angle or not. This will give me the minimum angle, because we are always going to measure it from the positive or the positive x-axis or the horizontal line to the right of, from measuring starting from this point, and I draw a horizontal line to the right, and then I measure this angle. So the smallest angle for Argz should be this thing, 90 degrees, because it's a tangent. This is the smallest. Then if I go to here, it will be a larger angle because we are measuring from here, 90, and going further it will be more. If we go for argument Z, going in this direction is negative. However, Z is not here. Is not anywhere in the third and fourth quadrant. Is not here. So we measure in this direction, and this is the smallest possible angle. Right. If Z is here, that is the smallest possible angle. Right. So that's it. Our argument for Argz, minimum value of Argz should be equals to 90 degrees. Right, if assuming Z is here. Right, if Z is anywhere else, it will give us a larger angle when measured from the origin. Like, yeah. So yeah, find the maximum. Then next, find the maximum value of Argz. You know, if Argz is here, the tangent, and this line is a tangent to the circle, it will give us the maximum angle possible, because we don't have anywhere further to this point. Any point lesser, if Argz is anywhere else on the circle, it will only give a lesser angle. So how do we get the angle though? How do we get this angle? So just now we found that the angle, minimum angle is the 90 degrees. Now the maximum angle is actually this angle. And how do we get the angle? Okay, we know that this is a tangent to the circle. assuming this is the line that will give us the maximum angle here, this must be a tangent to the circle, and this tangent to a circle, when we have the rule that says that every tangent to a circle makes a 90 degrees with the radius of the circle. Although this is not actually very well drawn, actually it should look like more like it should look like more like this is the 90 degrees. Yeah, this is the 90 degrees, and this is the radius. So radius always makes a 90 degrees with the tangent to the circle, right? So given that, and we should be able to, and this radius, I know that is the radius 2 from the earlier part. You know that this is the circle has centered at this coordinate has radius 2. So I know that this length is 2, and since I know that this point has coordinate -2 and 2√3, I can find this length using the Pythagoras theorem, right? And so then, using the simple trigonometry that this is opposite over hypotenuse, sine this angle must be equals to 2 over the Pythagoras theorem for the -2 square plus 2√3 square will give me the length over here, right? And if I do, sine theta will be opposite over hypotenuse, that's why it's this case. Then if I do a sine inverse of this value here, I will get my theta. And given that this line joins the origin to the center of circle, this is also radius 2, and the hypotenuse side is the same. This angle is also theta, right? So if we are able to add these two theta to 90 degrees, then we will be able to find this maximum angle, right? So let's see how we go about doing this, right? First thing, theta will be equals to sine inverse 2, then square root -2 square is 4, plus 2 root square will be 4 times 3 will be 6. Well, 4 times 3 will be 12. So 4 times 3 is 12. 16 square root is 4. Then 2 divided by 4 is half. So sine inverse half. And for sine inverse half, we know that this is just 30 degrees. You can key into a calculator to get that, or you can remember that some of the standard angles. Yeah. Okay, so theta equals 30 degrees. That means 2 theta would be equals to 60 degrees. And then the maximum value of Argz will be equals to 90 degrees plus this 60 degrees, so it will be equals to 150 degrees. That's how you get the maximum value of Argz, right? With this I end the tutorial. Any question, feel free to ask me again.